Connect. Is it visible?
Yes, sir.
Okay, we'll switch over to slideshow mode. Let's think. Is it visible now? Okay, check slide is moving or not on your screen. The slide is changing now?
No, sir.
Not changing.
No, sir.
Then we should not go slideshow mode. Okay, before we go for discussion about lithosphere, we should have a look on stratification of Earth. Like unlike your atmospheric classification or stratification, we have our Earth classified from the center to the surface to different zones. That the innermost zone is called your Earth's inner core, then outer core, then your lower mantle and upper mantle. Then you will have your crust, where crust is brittle and hard and rigid surface, and the part of the crust or upper part of the crust is called your lithosphere. Under lithosphere and above your lower mantle, there is a liquid and conductible media or a surface which is semi-solid, or you can say it is liquid, and the earthquakes are originated from that region, and magnetic fields also. That region is called asthenosphere. Okay. Below the lithosphere, you can imagine the asthenosphere. So from the top to the center of the earth, we can have your lithosphere, asthenosphere. Then you'll have your upper mantle, lower mantle, outer core, and inner core. If you see the structure and your composition, then the most of the elemental composition, whatever you have in your periodic table, that is 92 natural occurring elements, all are found at your crust composition, is in the crust. And if you go deep into the center of the earth, when you travel into the center of the earth, then you can see your composition is chiefly lie on iron, nickel, cobalt, and some very little amount of platinum is there, and most of them are iron. If they see the whole composition of the whole earth, then the maximum amount present in the earth is your iron. If you see the crust composition and check about the elemental makeup, then you will get your oxygen as 46 to 47% as highest elemental composition. So about the structure and makeup of your stratas in the earth surface to center, then you can find your surface or crust, which is called your lithosphere, where living organisms are there. This is very rigid and having less elastic property. Okay. The end of the lithosphere, when you go deep into the earth, and from asthenosphere it is very elastic, and the earthquake waves or seismic waves are begin from there, and the activities of seismicity and magma flow, convection, all these things occur in the asthenosphere, or you can say it is your upper mantle. Then
Sir,
you'll, yes.
sir ଟିକେ diagram ଟା show କରିବେ କି?
This is your diagram. Here, it is your inner core, the deep part, deep ball is your inner core. Then it is the outer core. Outer core is completely liquid. Then the dense liquid is your here, your lower mantle. Then your upper mantle. Then your lithosphere is the upper part. Asthenosphere and lithosphere. This from here to your surface, you will have upper mantle from this to this portion, and then your asthenosphere, then your lithosphere. The most uppermost part is your lithosphere. Lithosphere also contain your oceanic crust and continental crust. Means all the continents and the ocean floors are made up of lithosphere. And you can see the subductions also on the lithosphere. All the layers or stratas of the earth are divided or demarcated by certain change in the physical property, and these are called your uh, discontinuities. Means the property will change at certain point. If it is inner core property will change at certain point, and this is called a discontinuity. This discontinuity is called layman discontinuity, which is not written here. You can write layman discontinuity. And from the outer core to the mantle, the separation layer is called your cotton box discontinuity. And from lower mantle to upper mantle, there is another discontinuity is there. uh, I'll tell that discontinuity. Then you will have a more basic discontinuity, which divide your upper mantle to your asthenosphere or lithosphere, upper mantle to your lithosphere. That is called Mohr basic discontinuity or Moh discontinuities. So, what are these discontinuities? These discontinuities are a layer which will detect by change in or rapid change in a physical property, and which shows that we are going into another layer. Okay. So, if you see the structure and makeup, elemental makeup, then inner core is mostly made up of iron, and which is a solid, liquid, or gas. The temperature of earth will increase when you go deep into the center of the earth. So what is the inner core state?
Sir, solid.
Yes. So why it is solid? We have discussed in class sometime, I think. Why it is solid? Inner core is solid. Yes, correct. How or why? It is solid due to two things. It is at a very high pressure in the order of 10 to the power 6 to 10 to the power 8 pascals, and high pressure will make substances boiling point more increased. Means some substance have very highest boiling point. That means it will tend to have least interatomic distance. That means it will squeeze or shrink to solid state, because from the solid to the gas the intermolecular distance will increase, or interatomic distance will increase. So high temperature, high pressure, it will make the inner core a spherical solid ball made up of mostly iron. And some scientists have some research and findings that the inner core outer core discontinuity, that is called your Lehman discontinuity, will have some composition of platinum is there. Then you will have outer core also made up of mostly iron and some amount of nickel. Lower mantle is iron, nickel, and cobalt. Three are present, but dominant element is your iron. Nevertheless, your upper mantle is have the composition of this. Then you'll have your asthenosphere and lithosphere. Today we will discuss about lithosphere. So before go for lithosphere, we have look into the all the status of your Earth. So you can see lithosphere means rocky spherical surface on the surface of the Earth, which may have the granite or basalt type of mineral composition. And the lower part of the lithosphere, and you can say the asthenospheric, the upper part of asthenosphere, upper part of upper mantle, which is have the elastic property, and also it is called lithosphere asthenosphere boundary. And it have a viscous semi-solid substance with elastic property, and where the geologist and the rheologist scientists who study the flow of matter mark the difference in ductility between the two layers of upper mantle, means the asthenosphere and the lithosphere. Ductility measures the solid material's ability to deform the stretch and the stress. That means the stretching property of metal is called your ductility. Okay. The lithosphere is far less ductile, it is fragile, or you can say it is rigid than the asthenosphere. Asthenosphere have good elastic property and a ductile in nature. And that discontinuity, what we have discussed about the mantle, two mantles, that is lower mantle and upper mantle, that is called your repeated discontinuity. And your upper and lower crust means your asthenosphere and lithospheric discontinuity, which will divide the asthenosphere to lithosphere, is called conor discontinuity. But you should have this discontinuity in some topics or some books, and this discontinuity have very uncertainty in their property change. Only the elastic property and viscosity will decide the asthenosphere and the lithospheric boundary. And this is not regular. This is very irregular surface, which will uh, say the change in the asthenosphere and lithosphere boundary. Did you get all these discontinuities and this structure? You should have a draw this structure now. And if any doubt or in any information you need, you can ask. We'll go for discussion about lithosphere only. Okay, and some about plate tectonic. Draw this diagram or take a screenshot and ask if you have any doubt. Here the discontinuity is called Lehman discontinuity, which will divide or distinguish the boundary between the inner core and the outer core. And this is your Gotenbox discontinuity between the mantle, outer core and mantle, lower mantle. And this is your repeated discontinuity between the lower mantle and upper mantle. And this is your more basic discontinuity, upper mantle and your crossed. And this is your cono discontinuity between upper and lower crossed, means asthenosphere and your lithosphere. Okay, we'll go ahead. We'll have a look for a discussion about this plate tectonics. I think you know that the plate tectonics, though your upper mantle to outer core all are liquid or semi-liquid substances, and your crust is a very rigid and solid substance, and it is like floating. Some rigid plates are floating on a liquid surface. If uh, all the crust are intact or without any gap, then you will have very problem in art inner convection. It will occur. The convection will occur always inside the inner core, outer core and mantle. Due to that convection, the upper crust will, the floating crust will move from here and there. That movement will cause the fractures or fault lines. Means the crust is not intact body, it will have fractures, and that is called your plate zones or tectonic plate zones. So there are major tectonic plates are there, and also minor plates are there. So those major tectonic plates are moving always due to the mantle convection. So tectonic plate movement cause different type of landforms on the surface. If you'll see the about the movements of the tectonic plates, these tectonic plates have three types of movements. One is called convergent, another is divergent, another is transform tectonic plate movement. Convergence means when two of the plate are moving towards each other. That means the middle portion will folded up, and if one portion is going under another, that is called your subduction. That is called your divergence. Another is a transform, means that is called your transform. Another is your divergent, means in the ocean floor when volcanic eruption occur, the surface will made. That is called your ocean floor spreading. And at that point, this uh, surface formation process, here what will happen, the plates are moving opposite to each other. That is called your divergent tectonic plate movement. So due to this tectonic plate movement, earthquake occurs. Volcanoes and earthquakes are occurs. And this tectonic plate is due to the movement or convection of magma inside the mantle and the outer core. Here you can have this picture. The total radius of the earth is 6,378 kilometer, and what are the thickness? The thickness is measured here. The crust is your 0 to 100 kilometer, where your maximum 50 kilometer up to your lithosphere, and your outer core is 2900 kilometer and 5100 up to 5100 kilometer. It will spread, and from 5100 kilometer to 6378 kilometer, your solid core is there. Now we'll discuss about the composition of the lithosphere. We'll see this composition of the lithosphere means the upper part of the Earth surface or Earth crust. So it is not a homogeneous substance. It have different elements with including your sedimentary rocks on the top, granite and metamorphic rocks in the middle, and basaltic rocks in the bottom. Basalts are mostly made up of your iron. So it have more weight, means heavier rocks. So it should be in the bottom of your lithosphere. And also it will the bottom of your lithosphere, or that is called your lithosphere and asthenosphere border or boundary. Lithosphere asthenosphere boundary must be elastic. That means most of the metallic composition are there. That means it is rocky. This is a very iron rich minerals, that is called basaltic rock. Then your metamorphic rock or granites are there. It is formed due to the lava or the magma or volcanic eruption. When come out of the surface, it will cause your granites and metamorphic rocks. Sedimentary rocks are due to sediments, like in your river and other ocean floors. The substances when it will sediments and it will buried, and the layer by layer it will form the sedimentary rocks. So the total composition of the crust, if you see the composition of the crust, then oxygen is the highest composition or highest elemental makeup, that is your 47% around, and then your silicon 27%, then aluminum 8%, iron is your 5% by weight, then calcium, sodium, potassium, magnesium. These are some important or major elements in the crust composition. Why we are discussing about the crust composition? Because it is the lithosphere. Crust is made up of asthenosphere and lithosphere. Upper part of the crust your lithosphere. Mainly the crust composition means your lithospheric composition. You should remember this. It is evident from the above table that oxygen composition is 60% in terms of the number of atoms, and the volume of different atoms or ions is calculated, and oxygen makeup is more than 90% of the volume. You will say the volume, then oxygen makeup is your 93.8%. Do you have any problem or any question? I have a question for you, that why oxygen is maximum in the crust, and how it is possible oxygen is maximum. You know that from your school days that your uppermost crust layer is made up of silicon and aluminum. We'll have a division of or classification of element when you go deep or go deep into the center of the earth. Then your crust composition is changing, like your Cl means silicon aluminum, and Cma magnesium and silicon. Then Nephe, that is nickel and ferrous means iron. So from that composition, what we have read in the school, that is that should be silicon aluminum should have the highest percentage of composition in crust. And but we found that if you go for the element, then you will get that 47% is oxygen. Oxygen have maximum elemental makeup in your crust. How it is possible? I have a question for you. Anyone? Where the oxygen come in the earth, beneath the earth? Tejaswini? Are you listening,
Yes, sir.
Sonali? Uh,
Yes, sir.
how
Sir,
oxygen have the highest composition? Hmm.
सर मेनली जो
Hmm.
आर्थ जो कंपोजिशन थाए कि माने सपोज आयरन तो से ऑक्साइड फॉर्म करिकी रही थाए सेटे मेनली आर्थ क्रस्ट माने बेसी ऑक्सीजन लेवल थाए इन कंपैरिजन टू कोर एंड
Yes,
मेंटल.
yes. All the things, silicon in the form of silicon oxides, aluminum in the form of aluminum oxides, all the minerals in the earth surface of the earth crust are made up of oxides or hydroxides or sulfides. So you have read that oxides or sulfide ores or hydride ores. Okay, so that means most of them are made up of oxygen minerals. For that reason, the oxygen elemental makeup will be highest or composition will be highest in the crust or lithosphere. And if you go for the composition of the mantle, it will have 68%. This mantle have 68% of the total Earth mass, and it will have divided into upper transitional lower zones of mantle. And your upper mantle extends about 400 kilometers, and the region contains predominantly three silicate material that is called your olivine, pyroxene, and granite. Olivine, pyroxene, and granite are group of minerals, and all are made up of silicates, means SiO2 regimes. And the transitional zone extends from the depth about 400 kilometers to 1000 kilometers, and the above mentioned three components of the upper mantle are also present in this region but chemically modified forms. The lower mantle, which extends from depth of about 100 kilometers to about 2900 kilometers, the main components are magnesium oxide, iron oxide, and silica. And here also you'll have some change in the composition, but oxygen have 44%, again highest, then silicon 23%, then magnesium 19%. And you can see here silicon and magnesium are dominant if you see the metal composition. In non-metal section, your oxygen will be highest among them. Then like cross, the oxygen is most predominantly element in mantle two, and the oxygen in the upper mantle and transition zone is present in the form of silicates, and therefore the silicon is the second most abundant element in the mantle. Then composition of the core. The outer core extends from the depth of 2900 km to 5080 kilometers, while the inner core extends up to 5080 kilometers to 6370 kilometers. The inner core, which is in solid states, contains nearly pure iron, while the outer core, which is in liquid state, also contains predominantly iron, and the composition of the outer core is believed to be nickel and iron, what we have already discussed. Then if you see the surface of the earth, means in the lithospheric composition, there is another component which is very important for the sustenance of the biota on the lithosphere or between the lithosphere, that is your soil. And it is the shallow body, or soil is a shallow body of materials that is formed from the surface of the land, and it is the habitat of microorganisms and burrowing animals, means macrofauna. And more, it supply the material to indwelling members of the biota. Also, it will support as a substratum and the nutrient and the water to the plants or trees or photosynthetic organisms, which are the producer of the ecosystem. And without soil, there is no existence of any ecosystem or living system, whatever we are seeing now. So weathering of rocks, which will cause your soil. There are different type of weathering, that is your physical weathering, chemical weathering, and biological weathering. In physical weathering, you will have the change in the temperature due to the diurnal change and the seasonal change in temperature, and also your water or ice that is in the rainy days, and the change in the gravity, and sometimes the seismic activity will cause the rocks in regolith, but do not cause any chemical transformation of the rock. This is this is only cause the fractures, and this only cause the break in rocks, and the process is called your physical weathering. And it occurs in deserts and at high altitudes or latitudes, especially at places where sparse vegetation grow over the rocks. Means where least vegetation will grow, the physical weathering occurs. Then your chemical weathering, chemical transformation of the parent minerals occurring in the form of new mineral complexes. Water is the most potent weathering agent here, because water will make solubilize other elements, and most of the elements will be in the form of acids. It will form acids or alkalis, and the differential pH status in the form of acids and alkalis will solubilize the rocks like your gypsum, limestone, and those with the calcareous content gets weathered by the solvent action of the water. Then your biological weathering, and which is important for final preparation of your soil. There's certain organisms like your bacteria, protozoans, fungi, and nematodes, as well as lichens and mosses colonize the rocks and transfer it into a dynamic system, storing energy and synthesizing organic material. The organic material synthesized out of the rock material by these organisms, microorganisms or macroorganisms, are called mostly humus, or this is composed of humic acid and formic acids. And this humus and humic acid and formic acid will cause the fertility of the earth surface of the soil increased, and uh, it will make the other organisms like plants to grow upon it. And soil consists of the major components like your organic matter by the macro, including the microorganisms and the macroorganisms, that is 5%. Then inorganic mineral matter is 45%, water is 25%, and the air space or void space or the air in the void space are 25%. That means it will the total makeup of the soil. These are the major components. One is organic or biotic components, and inorganic mineral content, water and air. And also this soil is also classified into different zones. And first is called O horizon of the soil, then A horizon, B horizon, and C horizon. C horizon is nothing but your this is your lithospheric solid zone, and you can say it is a rigid or permanent rock, okay, or hard rock. And this is your B horizon, where your water table is there, or your water is there, and sometimes the large trees have the root network up to this B horizon. And A horizon is your organic horizon, and mostly the humus and other leachates. Actually, leachate horizon. This is called a leachate horizon. These leachates are stored in this A horizon, and in O horizon is mostly the inorganic, sorry, indigestible, or you can say the undegraded organic horizon. That means your litter deposition and semi-prepared humus are there in the O horizon, and it will classified as that from up to 2 inch at the depth you have a O horizon, then up to 10 inch, that is 2 to 10 inch, that is your A horizon, and 10 inch to 30 inch you have B horizon, and up to 48 feet, that is your C horizon. You can see in O horizon, that is humus, reaches the soil nutrients and enhancing the soil moisture retention. This is the top soil and top layer of the soil. It is usually 2 to 3 inches deep. And A horizon is the mixture of organic material and inorganic products of the weathering, and it is beginning of a true mineral soil. And this soil is typically dark colored. And B horizon or subsoil is an accumulation of mostly fine material that will move downward, resulting in dense layer of the soil. In some soils, B horizon contains nodules or a layer of calcium carbonate. And the C horizon, that is the soil base, include the permanent parent rock material and plus the organic and inorganic material that is broken down to form the soil. So beneath the sea horizon that lies your bedrock. What are the biota of the soil? So you can have the microflora, that means your fungi as your bacteria. Then your microfauna, that is protozoa, rotifers, mites, nematodes, that will have the size between the 20 micron to 200 micron. That is your microfauna. Then your mesofauna, which have a size between 200 micron to 1 centimeter. And your this part will include with the Hymenoptera group or order of organisms. Macrofauna, macroflora, which will include the hops, shrubs, and trees. Macrofauna are also there. That is your earthworm is a macrofauna, and other insects are macrofauna which live in the soil. They are also soil organisms and help in weathering of the soil or biological weathering of the soil. So we'll have already discussed about the atmospheric composition. This material also include the atmospheric composition. That's all about your lithospheric composition. If you are in doubt, you can ask. We'll go switch over to your hydrosphere. Any questions? No. One second, I'm sharing that. Hyd- Hydrosphere and see, is it visible?
No,
No,
sir.
sir.
Visible. Okay. Sharing it again. That is visible.
Yes, sir.
Yes, sir.
Okay. Okay. So that you are very familiar with this hydrosphere and hydrospheric structure and composition. If you see the hydrosphere, that means the portions where water is present on the earth and in the atmosphere also. So in the between earth and atmosphere, the water vapors, and in the form of vapor you will have your water, and beneath your earth or in the lithosphere, that is your groundwater is there, and also soil bound water, and also your capillary water is there. So these are called your groundwater, and most of the water are found in your water oceans, and you will have major oceans and five major oceans, and these oceans are the main source of your water. Then some amount of fresh water is also in your ice caps and ice sheets in the polar region. And another part of your fresh water is in rivers and other wetlands. So about hydrosphere, if you'll have a better knowledge about the hydrological cycle, then you can have the knowledge about the spreading or the composition of hydrosphere and how it will spread over atmosphere to the lithosphere. So, if we'll discuss about the origin of water on the Earth, then the most significant feature on the Earth evolution, in contrast to our other neighboring planet, is presence of liquid water that covers more than two-thirds of the planet's surface. And this water came about during the early days of the formation of the Earth, when the Earth's surface cooled down. The oxygen and hydroxides content is is the accreted material and diffused towards the surface. And these gases then cool and condense to form the Earth's oceans. It is believed that since then there has been a little loss or gain in overall quantity of the hydrosphere, despite minor fluctuations like a gain from continuity. For that means this will discuss about the conservation of the mass. Definitely, water mass is conserved. If you see, it will just move from one form to another, or one place to another place only. That means so water is vaporized from the ocean surface and is evaporated to the atmosphere, then it will condense and rain falls, and this rain falls through the land surface, and then it may leach into the groundwater, and it will have some water bound to the soil surfaces, that is as soil bound water or capillary water, and some water will be then to recharge the aquifers. So again, you'll have your major oceans, that is here you can see in the on your world map. The major oceans are the Pacific Oceans, North Atlantic Ocean, and South Atlantic Ocean, Indian Ocean. Then your Arctic Ocean. Okay, Southern Ocean and your Arctic Ocean. And you can see global water reserves with your ice caps in Antarctica. This is also your complete fresh waters. And the major drainage basins also there in the continents, and you can have here the Mississippi drainage basin, Amazon drainage basin, like that. Your Gangetic plain drainage basin in India. These are the drainage basins. There's a Congo drainage basin. These patches are the drainage basins, and that means your wetlands are there, which is originated from the different drainage lines. If you see the distribution of water across the globe by volume, you can see, or percentage, you can see also ocean have 96.5%, and the groundwater have 1.7%, Then your fresh groundwater is 0.76%, and soil moisture is 0.001%, and your glaciers and permanent snow cover is 1.74%, and out of this 1.74%, your Antarctica only have that 1.56%. Then water in lakes is 0.013%, where salt water lake is there and your fresh water lake is there. Then your marshes and swamps contain 0.0008%. That is your whole 100% of the water in the hydrosphere which will be distributed around your earth surfaces. And then here you will have the recycled water amount and your percentage fresh water and the volume of the water given in this classification. If you'll see the biological water, also you'll have biological water, also you have total volume of the water of the hydrosphere. This table is continued here. Okay. And you'll have total fresh water this amount, and total volume of the hydrosphere is this amount. This is in square kilometer. Until like it is this is a 1 4. You can see 1.386 million, 1.386 million square kilometers. And this thing you have known very well, that is your hydrological cycle. And this hydrological cycle is mostly driven to the evaporation and raining. Then you'll have advection, this marine atmosphere to advection due to radiation, solar radiation, to the terrestrial atmosphere. Also from the land, ice and snow and surface cover and underground water, and they have evapotranspiration or evaporation and transpiration to the terrestrial atmosphere. That means from ocean it will go from evaporation and advection to the terrestrial atmosphere, and here from the transpiration and evaporation by biological entities, also from the solar radiation, it will go to the terrestrial atmosphere. It will come back to the land and also ocean through rain. And ocean receives 390 units of your rain, where your land receives rain 107 units. Mostly evaporation maximum units covered from your ocean, that is 334, and from other parts it is your 71 units. This is your hydrological cycle, and some part of the water from the surface, means land, will go to the ocean through your riverine system, that is the 36 units. That means this whole interconversion of water and movement of water from one place to another in a cyclic manner, which is called your famous hydrological cycle. And if you see the biogeochemistry of a hydrosphere, that is from the chemical makeup or ionic makeup, then you'll have these things. That is, your chloride have the maximum in the seawater. This is chloride ion. This is the maximum. That is in ppm, parts per million. That is 19,000 ppm. Then your sodium is 10,500 ppm. You can see, if you think that the sodium chloride is present in the sea water only, then you will have the same amount of sodium plus and chlorine minus. But this acid radical will increase, this chlorine minus of chloride will increase, because this chloride also have the composition with other elements or other, like your potassium or calcium, means in the form of calcium chlorides, or also potassium chlorides are present in the ocean. Also, sulfates are there at 2,700 ppm, and magnesium is 1,350 ppm. Like that, fluoride is 1.3 ppm in the in your sea water, and you know that for drinking water purpose, this fluoride level is not permissible by Government of India as well as by WHO, World Health Organization. This is 1.0, I think, or 1.5 in max. And in the natural riverine water, you can have also chloride has maximum composition that is 5.75. Then sodium, the maximum composition is your sulfate or and your calcium, because calcium carbonate is rich in this riverine system, and CO2 is there, carbonate bicarbonate is there. Yes, bicarbonate is maximum in riverine system, that is your fresh water. You should remember that bicarbonate is maximum, that is 52 ppm is there. Then your calcium, because calcium carbonate is next to bicarbonate, means carbonate and bicarbonate. And you know that the hardness caused in water is due to bicarbonate, carbonate, I mean calcium carbonate, and magnesium carbonate. So that we are estimating the total hardness, that is calcium magnesium ion, in terms of calcium magnesium ion, and we are converting all the these water parameters into calcium carbonate equivalent, because the most predominant element or the ion in this fresh water is your bicarbonate and carbonate. Okay, and in rainwater, this is the composition, and this will change from place to place and time to time. So you have to remember this sea water composition and your river water or fresh water composition. And rainwater composition changes if you will have acidic less than 5.5 or 5.6 pH, then you can say it is acid rain. And acid rain have a different type of composition. It may have a carbonic acid, which bicarbonate converted to carbonic acid or sulfuric acid or nitric acid as composition. The sulfuric acid, nitric acid concentration in terms of acid rain, it may be due to the air pollution, or due to air pollution due to vehicular exhaust, or your coal-based thermal power plant or fossil fuel burning. Then you have your what's major water quality issues. That means pollution issues. This organic pollution have basically issues due to the river, lake, and groundwater pollution, and basically in river water pollution, the aquatic environment, and the pathogens also in riverine system, and the salinization problem in the groundwater, nitrate having maximum in groundwater, heavy metals in all water bodies, organics in all water bodies, and acidification in lakes and rivers, eutrophication in lakes and rivers, mostly in the lakes due to this is a lentic water body, and this is a lotic water body, flowing water body. Flowing water body have less eutrophication problem. And then your sediment load is maximum in rivers, and your diversions and dams and rivers and lakes also. These are major water pollution issues in the when we'll go through the hydrospheric structure and composition. So that's all for hydrosphere, and I think I have these materials on your group. I am also sending on your group other material. We'll go through the material, and if you have any question, you can ask at your WhatsApp group. And if you have any question to ask now, you can also ask. And you look into the biological structure and composition. You can go by yourself. I will send you the material. Biological composition means your ecological composition. Start from microorganism to higher organisms and plants and animals. And like your hydrosphere also, biological entities are in atmosphere, hydrosphere, lithosphere, everywhere. So they have all combined unit of all the biomes, including the microorganisms, are called your biosphere, or the composition of the biosphere. Any questions?
So I have a question about the lithosphere.
Yes.
The core region sir temperature और pressure maximum ଥାଏ sir बहुत ଥାଏ से region ରେ जो composition किंबा तांकर length किंबा तांकर जो data गुड़ा सब measure केमिति करा हुए
ମାନେ କୋର ର କଣଟା ମେଜର କରାଯାଏ?
sir core region ରେ हम जो distinguish गुड़ा अच्छी किंबा तांकर जो length केते ହେଲା
हाँ
कि
हाँ हाँ हाँ
केमिति
हाँ,
जोड़ा
that is
से region
yes, yes, yes. That is only measured by the magnetism or magnetic field change and your seismic wave pattern. माने earthquake wave ର pattern ଆଉ magnetism ର effect ରୁ ଜଣା ପଡେ solid state ରେ ଅଛି କି liquid state ରେ ଅଛି ଆଉ ତାର composition କେମିତିଆ। କାହିଁକି ନା ଆଇରନ୍ ନିକେଲ କୋବାଲ୍ଟ ସବୁତକ ହେଲା ଫେରୋମ୍ୟାଗ୍ନେଟିକ ସବଷ୍ଟାନ୍ସ କିନ୍ତୁ ସମସ୍ତଙ୍କର କଣ ମ୍ୟାଗ୍ନେଟିକ ଫିଲ୍ଡ କୁ ଆଟ୍ରାକ୍ସନ ସମାନ ଅଲଗା ନା ଡିଫରେଣ୍ଟ। ତ ସେଥିପାଇଁ କି ସିଜମିକ ୱେଭ ର ପାଟର୍ନ ଆଉ ତା ଇଣ୍ଟେନ୍ସିଟି ଆଉ କଣ ନା ମ୍ୟାଗ୍ନେଟିଜିମ ଏବଂ ତାର ଇଣ୍ଟେନ୍ସିଟି ଆଉ ତାର ଡିରେକ୍ସନ ହିଁ ଜଣା ପଡେ କି କୋର ର କେମିତି ଷ୍ଟ୍ରକ୍ଚର ଅଛି। Knowledge to reach there or by equipmental any measurement is impossible at core. You can see the layman's paper on the core composition and structure you can find online, and you can have the all the papers and publications of journals how they have estimated. They're clearly written about the seismic waves and how seismic waves and their patterns and the magnetism will help to know about the structure and composition of the core and mantle. Any other question? Okay, I'll stopping here. That's all for today. We'll discuss later.
सर
हाँ
सर सर ଏଇଟା ଆପଣ ପଠେଇଦେବେ ତ ସେଇଟା ପଢିକି ଆଉ ଥରେ ଯଦି କିଛି ଡାଉଟ୍ ବାହାରିବ ତ ପଚାରିଦେବୁ ଆଉ।
ଆମର ତ ଡାଉଟ୍ କେବେ ବାହାରନି, ମୁଁ ହିଁ ପଚାରୁଛି ଆଉ ବାହାରୁ ଦେଖିବା।
ସାର୍ ସେଇଟା ଆଉ ଥରେ ପଢିଲେ ଟିକେ शायद ବାହାରିବ।
क्वेश्चन ଯେତେ ପଚାରିବ ସେତେ ଜଣା ପଡିବ ତମ ଇଣ୍ଟରେଷ୍ଟ କେତେ ଅଛି ଆଉ କିଛି ପଢୁଛ ବୋଲି। ଏମିତି କିଛି ନାହିଁ କ୍ୱେଶ୍ଚିନ୍ ନାହିଁ, ବହୁତ କିଛି କ୍ୱେଶ୍ଚିନ୍ ଅଛି। କାହିଁକି ନା ସବୁବେଳେ ମନେ ରଖ ସ୍ଲାଇଡ୍ ରେ ଏମିତି ପଢିଲା ମାନେ ଡେଫିନେଟଲି କୋର୍ସ ବହୁତ ଫାଷ୍ଟ ସରିବ ଯୋଉ ବି ସାର୍ ପଢାନ୍ତୁ। କିନ୍ତୁ ତମେ କେତେ ବୁଝିଲ ତମେ କ୍ୱେଶ୍ଚିନ୍ ପଚାରିଲେ ହିଁ ବୁଝିବ, ନହେଲେ ବୁଝିପାରିବନି। ହଁ ମୁଁ ପଠେଇ ଦଉଛି, ଆଉ ଏଇଟା ଆଉ ଗୋଟେ ଅଛି ସେ ଲିଥୋସ୍ଫିୟର ବାଲା, ମୁଁ ସେଟା ପଠେଇ ଦଉଛି ଗ୍ରୁପରେ ହେଲା।
ଆଜ୍ଞା ସାର୍।
ଓକେ ଦେନ୍ ଓକେ
थैंक यू सर।
ଓକେ।